Hello, everyone, and welcome to today's session of linear equations in two variables. We have a lot to discuss today, as we all know about linear equation in one variable, but now it's time for double challenge. So, linear equation in two variables, kuch nahi hai. It's going to be very simple, very easy. Let's get started with first the general form. Okay, let's get started. Now, when we talk about general form, the general form comes as ax plus by plus c equals to 0. Now, what is this? Whenever we write a linear equation in two variables, we should write it in this form, right? Now, what are a, b, and c? Now, these are some real numbers. All a, b, and c are real numbers. And a is a coefficient of x and b is a coefficient of y, right? Correct? Does C have an algebraic coefficient or a variable coefficient? No. So C is just a constant. Correct? A, B, C, all are real numbers. Now let's move ahead and check if there are more conditions. The conditions are A and B respectively are not equal to 0. Yani A cannot be equal to 0 as well as B cannot be equal to 0. Is this a very difficult condition? No. You know why? Because if A is 0, then AX, ये पूरा term क्या हो जाएगा? This complete term will become 0. Again, same goes for this. If B is 0, so BY will be 0. Will there be any variables? No. If AX is 0, already one variable is out. If B is 0, again BY becomes 0. Both the variables are out. Our condition is it should be a linear equation in two variables. Correct? It should be a linear equation and that too in two variables. So we must note that as well. Now, talking about these things, do we remember that what was the condition for a linear equation? What was the condition for an equation to become a linear equation? Anybody remembers? So the condition was whenever it's an equation to become a linear equation, first the power of the variable should be 1. The power of the variable should be, must be, this is a must thing, that the power of the variable is 1. Now, do we have any constraints for the power of the coefficients, the numerical coefficients? No, nothing is such. So a is a real number, b is a real number, c is a real number. Can it be in roots? Yes, it can be in roots. Can it be in some exponential forms? Yes, it can be in exponential form. Their powers may be 10, 20 or 2 lakh. We don't care, right? What do we care about is x should have the power of 1 and y should have the power of 1. Basically, both the variables should have power of 1. Now, let's take an example. Suppose I have 2x plus y equals to 5, right? It's a linear equation in two variable. You all will agree to that. Now tell me something, like we did something in linear equation in one variable that we used to take out the value of the variable. Is this possible over here? Is this possible over here? Not at all. Why? Why isn't it possible? Let's check. Can x value be something? Can y? Oh, I have two unknowns over here, two variables. So how will I actually take it out? Suppose if I keep 2x on this side and I bring y to that side, it will be 5 minus y. Correct? It will be 5 minus y. So I can have many values of x and y. There are many possible values of x and y. So one very important observation is, note it down guys, when we have linear equation in two variables, we have unlimited possibilities of answers for one equation to have the values of x and y. Okay, x and y values can be different. Let's take for an example, when we consider x and y, how will we take out the value? भाई कैसे करेंगे, value कैसे निकालेंगे? Let's check it out. Start assuming the value of either x or y. कोई भी एक, ओके, चूज एनी वन, x और y with the lowest possible values, यानी x की वैल्यू तुम ले सकते हो 0, ये तुम्हारा लोएस्ट पॉसिबल वैल्यू। अब तुम कह सकते हो सर -1 -2 भी तो ले सकते हैं, भाई -1 -2 तो बिल्कुल ले सकते हैं, पर उसमें झमेला भी बहुत है, क्या क्यों करें? Why should we get into so much trouble? Let's make it easy, let's keep it simple, and let's take x as 0. Let's take x as 0. Okay, my first value x as 0. Now what will this equation turn into when will I have x as 0? So now 2 times 0 gives you 0. So now I have, this gives me 0 plus y equals to 5. Rather y equals to 5. So when my x is 0, my y is 5. Correct? Now this is our solution pair for x and y. Can I have more solutions? Definitely I do have. Let's check. Okay. Now let's increase the value of x and let's take x as 1. All right. I'm done. X is 1 now. So 2 times x. Now my x value is 1 right now. So 2 times y, that is 2. Let's take it as 2 times 1 plus y equals to 5. 2 plus y equals to 5. Let's take y equals to, let's take this 2 to this side. 2 becomes -2 when it goes to that side. Transposition method, very easy है ना, हम सबको पता ही है. So 5 minus 2, that is equals to 3. Now what is the value of y? Y is equals to 3. And in this way, if you keep doing the values of x and y with the assumption of one of them being one value, the other value will be automatically generated. So this is a very important thing. When we have linear equation in one variable, the value of the variable is fixed for that variable, that equation. Okay, when I have, suppose x plus y, okay, let me just give you an example. Suppose I have x plus 2 equals to 7. My x value must be 5, right? It's a unique value. Can I put the value of x as 6? No. Can I put the value of x as 7? No. Rather, can I put it as 1, 2? Nothing. It only satisfies, or it is only possible with only one unique solution, that is 5. But when we have a linear equation in two variables, we'll be having unlimited sets of values or solutions. All right. Now, let's get into some more discussions when we have pair of linear equations. Now, suppose what is linear equations in two variables in pairs? Okay, so basically we'll be comparing two equations over here, like something like maybe a1x plus b1y, plus c1 equals to 0. And the other equation can be a2x plus b2y plus c2 equals to 0. Now I have one pair of linear equations, basically two linear equations in two variables. Now they might have three cases or three conditions of solutions. Like the first one is a unique solution. Take a look into this. What is a unique solution? When there is only one common solution between both the equations. Now we just got a scenario in front of us when we discussed that a linear equation in two variables can have unlimited values, sets of values. So another linear equation in two variables can also have unlimited set of values. Now when we combine, how many common solutions do we get? For the first case, there is a unique solution. Unique solution means when both the equations will be having one single set of solution which is common in front of them. The second case comes as infinite solution. As the name suggests, it's very obvious. भाई अब तो सबको पता लग रहा होगा बात क्या है. When there are infinite common solutions between both the equations. क्या बात है? All the equations are just having, both the equations are having all set of solutions just equal. है ना? सारे solutions एकदम बराबर हैं. They are just equal to each other. Let's move to the next one. And there is another very bad thing. What is it? It's no solution. Oh my God. What does that mean? When there is no common solution between the equations. When there is no common solution between the equations. Now, guys, let me tell you that all of these have some graphical representations. As you know, linear equation in two variables can be represented in graph in Cartesian plane using lines, right? As it's linear equation, definitely it can be represented using lines. Now, the first one is unique solution. Okay, now unique solution, भाई एक mistake तो मैंने कर रखी है. Unique solutions कैसे हो सकता है? It should be unique solution, है ना? क्योंकि एक solution है. There should be only one single one. Okay, now take a look at this. This is a picture where you have one line. This is line 1, which represents one of the equation, and this is line 2 meeting at this point. Now this point, which is x, where x is equals to 3.6 and y is equals to 0.4, this is the common solution. This is the common solution where both the lines are meeting. So this is the unique solution point. Now can you tell me why is it unique? Let me tell you this thing. Will these lines meet anywhere further again? No, never. So what's this? This is pretty simple. Both the lines come and intersect at this point, and this is called a unique solution. Now, how will the infinite solution look? Let's take a look into that. We have our infinite solutions. Now, what is this? Do you see two lines? No, there's only one line. Why? Because two lines are one on top of the other. The both lines are coincident on each other, overlapping each other, like just like one on top of the other. Oh, I'm making a mistake. Now you'll say that your drawing is so bad. I know my drawing is bad, but what can I do? Lines are really tough to be made with bare hands. Okay, now this is cool. Now take a look into this. There's two lines. I mean, there are two lines over here, one on top of the other, but still you can't recognize the two. Why? Because they have the same set of solution. They have the same set of solutions and infinite solutions, because both of them have infinite solutions independently, right? They have an infinite set of solutions, and when they combine together, they are just on top of the other, so they will have infinite common solutions. And let's go to the last one where we have no solution. By this phenomena is very common to all of you. This is called parallel lines. When two solutions are having parallel lines of representation, they will never meet, because we know parallel lines never meet. They maintain equal distance within them as far as they are stretched. Correct? So with that, that comes to an end of our today's discussion. So what did we discuss, guys? We discussed no solution, we discussed infinite solution, we discussed unique solutions. What are these? These are a pair of linear equation in two variables, different types of solutions. Okay, I hope I made it really clear with all of you. And that brings us to the end of our today's session. Let's meet on the next day. Thank you so much.